Differentiate polynomials. Polynomials usually just refers to the fact that there are several terms. Terms are separated by plus or minus signs. So as we look at this, basically what we're doing is we're doing d dx of the 5x to the fourth. You can use the minus sign or the plus sign, and d dx of the 2x cubed, and I'm just using minus signs here, d dx of x squared. So when we look at this, basically you're looking at each term separate. So I just kind of think about the plus and minus signs, separating these, and then we're doing our derivative trick on each one. So the first one, the 4 moves out front, so it'd be 5 times 4, x to the 4 minus 1. I'll just show my work. I know some of you can do it in your head. 2 times a 3 moves out front, and then it's 3 minus 1. And the last one, 2 moves out front, and 2 minus 1. And the exponent turns into 20x to the third minus 6x squared minus 2x. And that's all there is to it. So that's the answer. Okay. So 20x to the third minus 6x squared minus 2x. So the trick is when you look at these, you're breaking it apart in terms, and the derivative applies to each term. Next one, same kind of problem, but now they're asking us also to evaluate or plug in a number at x equals 1. So the first step is we find the derivative with respect to x, then we plug in the number. So I'm going to go ahead and just streamline it. The derivative is basically applying to each term. It's almost like a distribution idea. All right, so that's going to be 2 times 4x to the 4 minus 1. I'll keep showing my work for now. Plus 3x to the 3 minus 1 plus 3 times 2 to the x times x to the 2 minus 1. That becomes 8x cubed plus 3x squared plus 6x. And then we want to find out at x equals -1. Okay. So I'm getting caught up in my notation here. So I'll put a colon to kind of separate it. Okay, so that's separate. All right, so we're plugging in x equals -1 wherever we see an x. So 8 times -1 cubed plus 3 times -1 squared plus 6 times -1. All right, simplifying, negative to an odd exponent will be negative, so that's 8 times -1. A negative to an even exponent means the output will be positive, so that's 3 times 1. And 6 times -1 is -6. Okay, all that turns into -8 plus 3 minus 6. So that's -5. I got -11. Okay, so the trick is we do the derivative to each term, and then if it's asking us to evaluate it at an input or a value, then we would just plug that in after we've done the derivative. And same type of problem, do the derivative first, then plug in 3.